Hey, Math 8, this is Mr. Bainey, and we're going to take a look at what's up, Math 1. We're going to take. Hello, this is Mr. Bainey. Let's take a look at 18.3, which is corresponding parts of congruent figures are congruent. I'm going to abbreviate this, and every time I write C, P, C, F, C, right, that is shorthand for corresponding parts of congruent figures are congruent, and that parts refers to angles and also sides. Okay, so the corresponding parts means the corresponding angles or the corresponding sides. And we're going to eventually get to writing some proofs, which we saw an introduction to some things that will help us write proofs in 16.4. So definitely go back and review that lesson if you need to. Here on page 910, you'll see the statement for corresponding parts of congruent figures are congruent. So it's written as an if-then statement and starts out with the fact that two figures will be congruent. So it could be two triangles or two quadrilaterals. And if they are congruent, that means the corresponding sides and the corresponding angles are congruent. So let's look at exactly what that looks like. On page 911, let's take a look at your turn number 5 and number 6. So here we have two congruent triangles. It actually gives us a congruent statement right here. And going back to, I believe it's the very last lesson, 18.2, when we wrote congruent statements, probably for the first time, the order of the letters is very, very important when we write them for figures, because the first letter in one figure is going to correspond to the first letter in the second one, the second to the second. So that means if I look at, let's see, angle S, that's going to be congruent to angle V. I'm going to mark that on my picture. So you'll see angle S and angle V. I marked that with just one little arc. Angle T is congruent to angle W because those are both the second letter. So I'll mark that with two arcs, T and W. And lastly, angle U is congruent to angle X. Those are both the third letter, and you'll see me mark those with three arcs. Those are just the corresponding angles. Each triangle has three angles. They also have three sides, so there are three pairs of corresponding sides. Again, the order is important. ST is the first two letters of the left triangle, and VW are the first two letters. When I say that, remember, I'm looking at my congruent statement. Okay, ST is here, and then VW is the first two letters. So those two sides are congruent. I'm going to mark that on my picture. Here's ST and VW right here. Mark that with just one little tick mark. TU is congruent to the segment WX. Again, mark that on the picture. And the final pair of corresponding parts is SU. That's the first and third letter. That's congruent to the segment VX. I'll mark that with three little hash marks. Okay, so those are all the corresponding parts. And remember, we know those angles and sides are congruent because of this. Remember that the CPCFC means that if we know this, then we know this. So number 4 asks for the length of SU. SU corresponds to VX, so I know those will have the same length. So if I look at SU is this really long side row right here, so if I look at VX is 43 feet, which means that SU also has to be 43 feet. So that's our answer. They're both 43 feet. For number 5, the measure of angle S is this angle with one arc. That corresponds to angle V over here. Angle V measures 38 degrees, and that means, actually, let me write down the equals measure of angle V here, because they have the same measure, and that's 38 degrees. Okay, and that's it for those. If they just tell us the measures of certain sides and angles, right, we just look at what's corresponding to what. Just below this, your turn, are some properties of congruence. These should look familiar. They look like the properties of equality that I think goes all the way back to, I want to say 16.3. It's one of the lessons in Module 16. But there are a lot more properties of equality than congruence. But we do have a reflexive property of equality and symmetric property of equality, transitive property of equality. And you can see here that they also apply to congruence. Remember, equality means we use equal signs, and they represent numbers. Congruence means they represent figures. So this is a figure that's a segment, right? A figure that's a segment. So we say those are congruent. If we talked about just AB, that means the distance from A to B or the length from A to B. So we use an equal sign. So that particular statement would be the reflexive property of equality. Okay, and that's the difference between both. Very, very similar. So I'm not going to worry if you confuse congruence with equality. I'm not too worried about that. Okay, going away from our properties just for a quick moment, we are going to look at another example where we're going to look at our corresponding parts. So in our directions, it actually tells us this congruent statement. Okay, I'm not going to write down all the corresponding parts because there's a lot. But angle G would correspond to angle M. Angle H would correspond to angle M. Okay, and there's a lot more, like I said. So let's just go straight to doing number 6 and number 7. If you want to pause these and try them out, or pause it after the first one and try the second one, go right ahead. But let's look at LM. LM is this side over here. Well, let's look at what LM, it should correspond to one of the sides here. So remember, we look at our congruent statement. LM are the first 2 letters over here, which means it's going to correspond to GH. So I'm going to mark that on the picture. LM is here, the blue tick mark. GH is here. And because they're sides, it's the one that has the centimeters, right? Make sure you don't use the wrong one, right? Or that one. It's a length, so it's in centimeters. So I know that this is equal to GH. LM says it's 6x minus 13. GH is 4x plus 3. So we just solved this equation. We set up the equation by looking at what's corresponding. So I'm going to subtract 2x, not 2x, subtract 4x on both sides. I get 2x minus 13 equals 3. Then we add 13 to both sides. So 2x is 16. Then divide by 2. Right? X equals 8 is not our answer. That just helps us get to our answer. If x equals 8, right, we're going to use, that's LM right there. We want to find out what LM is. So we do 6 times x, or 6 times 8, and then we subtract 13. So that's 48 minus 13, which is 35, and this is in centimeters. So that's our length of LM. Okay, with number 7, measure of angle H. Let's see, that corresponds to, H is right here, the second letter. That corresponds to M. So measure of angle H equals the measure of angle M. The measure of angle H is given by 9y plus 17. Remember, I find that up here. Here's H, and it's this angle, which is the 9y plus 17. Measure of angle M is given by 11y minus 1. And just like number 6, we have our equation. We just go through and solve it. If I subtract 9y on both sides, I get 2y. And add 1 to both sides, I get 18. I did 2 steps at the same time there. Divide by 2, and we get y is 9. Then I need to plug the y into there, right? Measure of h, angle h, is the 9y plus 17. So I'm going to do 9 times the y, which is 9, and add 17. And what is that? 81 plus 17, which is 98 degrees. And that's our solution. Okay, now we are getting to our proofs, which is going to be one of the more challenging things that we do in geometry. So just below the example we just did is an example of a written proof. Let me just tell you the structure of this. On the left side, actually, let me go back up here to the beginning. We are going to have a given statement, right? This is like our just the information that we know from the beginning. Here, we usually have a picture that's drawn for us, and then we have the proof statement. The proof statement is like our answer. It's very similar to, this is unrelated here, but if I told you to solve the equation, 6x minus 13 equals 4x plus 3, but what if I told you already the answer is 8? Then what we do in a proof is we figure out, well, what are the details in the middle? Can you prove that this thing actually is equal to 8, even though I told you the answer? And that's what we're looking to do with these geometric proofs. We have our our given statement here. We have our answer, right? And then we want to figure out, well, how do I get from here to here? I'm going to do a couple of these proofs. And I did forget to mention that previous page. Yes, we have 2 columns, so it's called a 2-column proof in some books. The left column is always our statements, our mathematical statements that we're making. And then the right side are the reasons why we can make those statements. Okay, so number 8, let's write a proof. We're given that triangle SVT is congruent to triangle SWT. So here's SVT and here's SWT. Those 2 triangles are congruent. And remember, we know a lot of things are congruent when 2 figures are congruent, right? That's the CPCFC. We want to prove that the segment ST bisects angle VSW. So ST bisects the angle. So you need to know what that means and the result of it, right? Bisect means to cut in half. And if you bisect an angle, we're cutting the angle in half. Well, cutting in half means that there's 2 angles, and the 2 angles are both equal to each other, right? So this one is equal to this one, or it's congruent. So what I'm going to do is, in every proof, we always start with our given statement. So our given statement is triangle SVT is congruent to triangle SWT. You see I left a little bit of space right above it, and I'm going to leave some space on the right side for our other column. But I'm not going to get there quite yet. Our second statement is, remember, we need to fill in some details in order to get to our answer. And my answer I want to get to, I'm going to do some backwards brainstorming. And segment ST bisects angle VSW is our so-called answer, our proof statement. So what does that actually mean? It means that this angle, let me write this down. We want to know that angle VST is congruent to angle TSW. which is this one right here, right? If we know that that's true, then ST is the bisector, right? Because it's cutting it in half, the big angle in half. Well, do we actually know this is true? Do we know that angle VST is congruent to angle TSW? Absolutely, we know that. We know it because, check it out, VST, S is the vertex. So look at our congruent statement. Just look at statement number 1. S is the first letter, right? That's S from this triangle, the top triangle, right here. And S in the other triangle is also the first letter. So it's this one right here. So that means these two angles correspond. They correspond to each other. So we know they have to be equal. Sorry, not equal. They have to be congruent. Right? They have to be congruent because they're corresponding and the figures are congruent. And then we can actually say in our third statement that segment ST bisects the angle, because we have enough information to make this statement. Okay, I'm going to erase my statements in red. So we just finished making our statements that we need to make. So I'm going to draw my horizontal line there. These are our statements. And when we do our next one, I'm not going to write down the word statements. I'm just going to put an S there just to abbreviate, because on the right side I can write S, and on the left side I write S. On the right side I can write R to mean reasons. So the reasons are asking, why am I allowed to make that statement? The first reason, always easy. That's the given statement, right? I can make that statement because it was given to us. Statement number 2, angle VST is congruent to angle TSW. Remember, we can say that because they're corresponding, which is the CPCFC. Corresponding parts of the congruent figures are congruent. And our reason number 3 is, this one's a little bit trickier, but because the angle, because the top angle and the bottom angle are both the same, right? That goes to our definition of angle bisector. The definition of an angle bisector is that the bisector cuts the angle in half, right? And cutting it in half means that one of the parts of the angle is equal to the other part of the angle. Okay, so I do allow you to use the index cards on your assessments. Please make sure you're including those definitions, especially this one, the angle bisector, and things like midpoint and stuff like that on index cards. Let's go to number 9, our first statement. Okay, we got a couple of statements to put together here in statement number 1. So I got quadrilateral ABCD is congruent to quadrilateral EFGH. I'm saving myself some space here by not writing the word quadrilateral. And segment AD is congruent to segment CD. I'm actually going to mark on the picture that second thing, which is the segment AD and segment CD are congruent. Notice that segment AD and CD are from the same shape, right? So they don't correspond, because you would have to correspond one side from this quadrilateral to the other quadrilateral. Okay, before we make statement number 2, let's see where we need to head towards. We want to prove that segment AD is congruent to segment GH. And that is this one here on the left, AD, and segment GH on the other quadrilateral is on the bottom. So the first thing that we can check is are AD and GH corresponding, right? I can tell by looking at the congruent statement, AD. Those are the first and fourth letter. GH is the third and fourth letter. So those don't correspond. right? We can't say that they are congruent because they correspond. That's what I mean. Well, what does AD actually correspond to? AD, remember, is the first and last letter. It corresponds to EH. So I'm going to write that down. Remember, we're brainstorming here in red. Those correspond. And GH from the second quadrilateral corresponds to CD. Okay. So I want to know out of these, what do I actually need to get here? Okay, if I already know this is true, the AD is congruent to CD, then what else do I need to state to get to my last proof statement, right? If AD is congruent to CD, then this, I'm going to circle it in blue, this is going to help us because AD is congruent to CD, GH is congruent to CD, right? Notice that GH and AD are both congruent to the same thing. So that means AD and GH are both congruent to each other. All right, we don't need this statement right here because EH is nowhere in anything else. So that's not going to help us. It's this one that helps us. So I'm going to write down that statement. You might, if you don't see it yet, this might help you by writing it over here. So CD, segment CD is congruent to segment GH. And then we can finally say that segment AD is congruent to segment GH. Okay. I'm going to erase all of that. Now we got to write our reasons. So here's my horizontal line statements. And then on the right side, reasons. Reason number 1 is the given. Reason number 2, why can't we make this statement segment CD is congruent to segment GH? That's because they correspond and the figures are congruent. So CP, CFC. Reason number 3, because we had to combine segment AD and segment GH are both congruent to the same segment, to CD. That means AD and GH both have to be congruent to each other. That is the transitive property. Okay, look at those 3 statements, including the statement number 3. And go back and look at your transitive property of congruence just a few pages back and see if you can notice that they're the same thing. Okay, that's going to be it for this lesson. I hope it was helpful. Definitely try out some of the proofs. I recommend starting with the statements, trying to brainstorm, like go backwards from your answer, your final statement, to figure out what you would kind of put in the middle here. Some proofs will require more than 3 statements, right? And some could be even shorter. So it all depends on the problem. Okay. All right. Thank you for watching. Have a good day.